is a propulsion machinery design. There's the electrical system. There's outfitting. There is say different domains we can say. Say this is mechanical or solid mechanics or structural mechanics. This is engine combustion something. Right? This is electrical engineering. And this is hotel facility something, kitchen something. Airplane. Airplane is very sensitive to weight. So if you design a wing of airplane, you should find the area of the wing to make enough lift force, right? To lift up whole weight of the ship. Right? Same as buoyancy of the ship. Right? Buoyancy always balance with the weight, total weight. Airplane, the total weight is balanced by lift force made by wing, right? So I designed the airplane, let's say, right? Initial design. But I found that the area is enough to make a lift force. The shape of the airfoil is okay. But I found that the connection part of the wing and main body is weak, structurally weak, because half of the lift force should come in here, right? So it should be strong here. Right? So I found this one by calculating or simulating the structural strength calculation, FEM something, finite element method something. So I should increase the thickness of some structural part over here. Right? Then what? So I increase the thickness size.
Increase the weight.
Weight is increased. Then what happened? I should increase the area of the airplane a little bit. Yeah? 5% or 3%, I don't know. We should calculate. Right? Then what? You need more strength. 3%. So it's a roof. Right? The number is decreasing, but still is looping. Endless loop, so to speak. So you need to have enough, say, 10% more strength or 20% more at the initial time. Then you can reduce the cycle. But this is only one example. See, if you increase the weight, then you should increase the size of the engine too. Right? You need more propulsion power to have a same lift force and speed. And then it increases also weight of the airplane. Also, you need to increase the fuel tank. Right? And you need to carry more fuel to fly to the Los Angeles. That also increases weight. So it's very complicated. So I'm saying interdependency between domain branches or technologies. It is high for what? Closed system. Airplane, ship, space shuttle. Right? They are closed system. Building is a kind of semi-closed system. But it's very open. We can open the window, we can have a sewage pipe going out, electricity is coming from the outside. So we cannot say it's a closed system. It's a kind of half-open system. Your body is a kind of closed system. Right? Not completely closed, but a kind of closed system. So you need to have a more interdependency between components of your body. And in that case, the system design needs to have a roof style. We call it iteration of design. Special to closed systems. And big complex closed system. You need to have a roof kind of. Right. Right. We don't have enough time. Schedule. Design process of ocean plant. Ocean plant is a very big and complex system. And also see, it is operating inside the faraway deep ocean with a big wave and wind is coming. So it's a closed system. Right? So it is complex procedure. And change management. Because it is very complex and big, there are so many changes. Right? See weight and area, strength, propulsion, gas oil tank, they are all dependent. So one change gives you spread of another changes. Right? So it is also keep running. So we need to have the good way of managing design change. Here's another one. So you already see that client is who? Who is client? Of the ocean plant? Oil company. Right? Big oil majors. Oil company. And engineering company, we can say this is a design company. And company is usually small. But for the design process, we are talking about design process. The engineering company is the main body. For the design. That's why the drawing is big. And vendor, who is vendor? Vendor. They are saying, what is it? Document and submission and comment. What are vendors? Constructor. Equipment supplier. So the process is typically divided. It is explained by Professor Zhang last time, but you may miss this. This is engineering and procurement and construction. There is a main part. So we call this EPC contractor. EPC contractor. Shortly. So engineering is designing. Procurement, buying materials, buying equipment, components, right? And see construction, assembly. Say for say automotive company, Hyundai Motors, we usually say one car is made of 20,000 components. 20,000 components. Traditional counting. Depending on how do you classify, but usually we are saying 20,000 components per car. So Hyundai Motors, they purchase 20,000 components and assemble them and produce car. Right? Easy. So procurement is very important. Right? For the ocean plant or for the nuclear power plant, how many components you can expect? How many? Maybe 10 times more than a car, right? Mm-hmm. At least, right? Depending on how you divide them. So vendor is for providing such a component. in plant engineering, they are saying vendor. But there is another kind of, there are so many vendors. Vending machine is a vendor, right? Vending machine. But anyway, vendor is our suppliers, part suppliers. So it's important for them. Client is also important. They provide money. Right? And then this is a process. Design basis. They started from design basis. This is a requirement and specification and code. Requirement is this ocean plant should operate in north coast of Australia, between Indonesia and Australia, 10 kilometers away from the coast. Water depth is 2 kilometers. And then reservoir is made of only gas. That kind of thing. And you should produce gas 1 million barrel per, not is a barrel, cubic meter, something like that. So that kind of thing is a requirement. Simply say, if you want to buy your PC, you should have a list of requirements. Or if you want to buy your smartphone, you should list up what do you want for my smartphone, right? There is a user requirement. Or if you want to buy your house, your car, you should list up what I want. Right? But also, at one hand, you should have a money, a budget, right? For me, I cannot spend 1 million won. Probably 500,000. 500,000. Yes, that is maximum for my budget. And then I should reduce down my requirement. Right? So that is, we say, functional requirement. And then specification. Specification means I should have 5 gigabyte hard disk memory, something, or main memory, flash memory, something, and also screen size should be 14-inch wide. Something. That is my specification. A kind of requirement, but specification is a numbers and specified requirement, specified exact requirement. In terms of broad requirement, saying I want to build a good, nice home. Please build a very good, modern home for me. There is a kind of another requirement, but specification is very exact one. This is a mixture. And this is a design code, is a regulations, laws, regulations, safety code, something like that. And then the designer should produce drawings, right? Drawings. And also the document for purchasing equipment or parts. So we call this is bills of material. So there is an output. It's an input to the designer and output from the designer. Good. I should continue. And this is more same picture, but a little bit different. Vendor is here. It can be placed here, but anyway. And client, it goes, the output is go to the vendors and also to the client. So that is and concurrent engineering. I only explain this slide and then finish. Concurrent engineering saying it is very similar to parallel processing. Parallel processing of a computer. Supercomputer has a parallel processing. Multiple CPUs. They do calculation together, right? Supercomputer, parallel processing. Similar one. So they do EPC, right? EPC. It should be sequential. Design, and then procurement and construction. Right? There's a sequential. But they, from sequential to concurrent, they want to overlapping the process. Why?
Save time.
Hmm?
Save time.
Same time, right? To reduce time, because there are so many competition, right? This is coming from LG. Right? I am using LG phone. But Samsung is producing new design every 6 months, right? Then what should I do as an LG man? I can provide a new design by 5 months. That's better for my competing power, right? Competition. Apple is doing too, right? Xiaomi is doing. So they are running competition. So time is very critical for nowadays. More critical than price. Time is more important for competition nowadays. So it's coming to the reducing time. But what happened? The problem of reducing time, what can happen if I start my work before finish of design? What can I purchase? What can I construct without drawings? Anyway, they want to do parallel process. So the problem is, if I change my mind as a component designer, then purchase should be cancelled and the other one should be purchased. Right? So there are so many changes comparing to the sequential ones. Right? Possibility of changes are higher. Right? This complication is more complicated. Still, I must do that because of the market competition is higher. Xiaomi is doing, Samsung is doing, Apple is doing faster than me, then I can lose my whole market. Right? This competition. So I should find out how to handle this complication and still maintain the quality of the product. Reduce time, quality, cost. So there are 3 important topics of competition: is cost, quality, and time. 3 most important components. Always we compete in the market with these 3 components. So, but I'm saying nowadays this is more important than the other 2. Modern market, time is more critical. So concurrent engineering, but it's complex. So you need to have a more engineering power, higher level of engineering, right, to compete with such a complex design environment. So we'll see more next time. I finish up my, so we delay. All right. So we'll see on Monday next week.